video is on solving an assignment problem. So we'll just get underway with an example on how we can solve an assignment problem. So let's have an example first. So you might have 5, 7, 6 and 5 again. Then you can also have 3, 9, 4, 7. This side you can have 2, 2, 5, 7. Then here 8, 6, 7, 8. So these are, should I say, possible allocations to various jobs that can be available. Okay, something like that. So you can have like job 1, job 2, job 3 and job 4. So you're trying to find on how you'll be allocating these jobs to those particular operators, like operator A, operator B, operator C and operator D. So you want to give one job to one operator. That's the row at the end of the day. So how will we do this? So the first step is that when you're solving an assignment problem, the first step is make should I say row reductions. What do they mean by row reductions? That simply means that you got your rows. Your rows are those that are along number 1, number 2, number 3, number 4. Those are your rows. So what do you mean by row reduction? You would start by looking at each of your rows and picking out the least number in that row. Once you identify the least number in that row, subtract it throughout in its respective row. So like for example, row 1, which has 5, 3, 2, 8. What's the least number there? It's 2. Meaning we'll subtract 2 throughout in that row and see how this matrix will be reduced. So the whole point of doing this is to reduce the matrix to a certain state. So let's start by that. First of all, let's identify the least numbers. So for row 1, I'll come and use a 2. For row 2, I'll come and use another 2. That was the least number there. For row 3, I'll use a 4. For row 4, I should use a 5. So these are the numbers you come and be subtracting throughout their rows, and you'll see to what outcome the matrix will change to. So let's get underway. So what I want to do is that I want to be writing my answers on this other part here, this side. So I want to just bridge a line between these two matrices so that when I start drawing, there will be no, should I say, interference. So let's start with the first row. 2 minus 5, 3. 3 minus 2. Remember, it's 2 subtracting everything in that row, which is just going to be 1. 2 minus 2, 0. 2 minus 8 is 6. Next, we're in row 2. We said row 2, the least number there is also a 2. So we're going to subtract like 2 throughout that particular row. So 7 minus 2, 5. 9 minus 2, 7. 2 minus 2, 0. 6 minus 2, 4. Next, third row. This list is 4. So 4 will be subtracted throughout that particular row. 6 minus 4, 2. 4 minus 4, 0. 4 minus 5, 1. 7 minus 4 is 3. Next, 5, the last row now. Last row, the least number is 5. So 5 will be distributed throughout. 5 minus 5, 0. 7 minus 5, 2. 7 minus 5 again, 2. 8 minus 5 is 3. You have made what they call your reduced matrix after making row reductions. what next from here? After making row reductions, you have a new matrix on your right hand side, as you can see. The next step is do the same thing on this reduced matrix and now focus on column reductions. So from row reductions to now column reductions. So I'll just see, let me see what I can do. So that I want to erase the whole page so that I show that okay, we are now with this matrix that has been reduced. The one which I want to just circle, this is now like our new focal point. We'll focus on this new matrix now. So from this new matrix is where we'll begin to compute the column reductions, and then from there we'll be able to now find another reduced matrix. So let me just quickly like erase what's on this screen so that now I can start the column reductions. So at this point we are now looking at column reductions. Column reductions are those now, these ones which are like vertical, like for example 3 5 2 0, that's the first column. The second column is 1 7 0 2, third column 0 0 1 2, fourth column 6 4 3 3. So we want to now make column reductions. Same story, pick the least number in that column. Once you identify it, you subtract it throughout that particular column. In the first column, what's the least number? 0, meaning nothing will change. If you subtract everything from 0, it will be the same. So it will be 3 5 2 0. Next, second column, least number 0, nothing changes. Also, when you subtract 0 throughout, everything is maintained. Third column, 0 is the least number, meaning everything comes back the way they are. So them. Third row, I was saying nothing will also change because the least number is a 0, meaning everything in that row comes back the way it is. Fourth row, the least number is a 3, although there are 2 3s, but of course just choose one of them. So the least number is a 3, so if you subtract 3 throughout, you have 3, then you have 1 0 0. You have made another reduced matrix. What next? Well, the rule states that after you have done your row differences and your column differences, try to now allocate jobs based on the values that will have 0. Try to allocate jobs based on the values that will have a 0. So we will now shift our focus looking at this now reduced matrix that is on your right hand side, and try to allocate jobs based on the numbers that have 0. So like I'll start with let's start with the first row. If you look at the first row, you've seen a 0, right? The one is 3103. There's a 0, meaning if there is 1 0, this is another criteria that we use when allocating jobs. If there is 1 0 in a particular row or column, you can cross it out. Usually that's the row, meaning it's taken. That's what we actually understand by that. So if there is 1 0 in a row or a column, just know that you have to cross it out, showing that it's taken. So how do you cross out? If you're picking from a row, usually we cross out like this. So like I'm in the first row, I found 1 0. How do we cross out? We cross vertically like this. If you've seen what I've just done, a vertical line, meaning we should not come back to this erased, should I say, column at that point. Yeah, so what happens is that if there's 1 0, always remember that we have to draw a line to show that, okay, in short, that whatever falls under that 0 has been already handled. Okay, so we even tick, showing that this is 1 0 has been allocated. Okay, then we go to the next row. Do we have any 0? No, we just cancelled out. If you noticed in the second row, there's 5 7, then 1. So there's no 0, we go. The next row How many zeros are there? 2 0 and another 0. In a scenario like that, do not cross out. We only cross out when we find 1 0 in maybe a row or a column. So we skip. Because why have we skipped? It can be any. You can either allocate this first 0 or the other 0. Now we do not use ambiguity or trial and error in assignment. The rule is that to just avoid making any errors, when you find 2 zeros, just skip. So go to the third. So go to your last row, which has 0, 2, and another 0. Basically, for that one, which I'm just going to do is that you also skip. Same story. You are viewing them through what? Through rows. Change your view and start also scanning through rows. This is what they call row scanning. And now we are going to shift our scanning to now column scanning. Let us also scan through the columns. Can we also allocate maybe using column scanning? If you look at the first column, 3520, are there 2 zeros there? No, there's only 1 0. So once you just find a row or a column having 1 0, cross it out, meaning it has been allocated. So we have found a 0 in a column, right? Meaning, how do we show the cancellation? We use a horizontal line. We just take note of these rules. When we have identified a 0 using column scanning, when we are cancelling out, we use a horizontal line. When we have found a 0 using row scanning, we cross out that 1 0 that we have found using row scanning using a vertical. So just take note of those two rules. Yeah. So you'll find that, okay, I've done for the first column. Let's go to the second column. The second column has 1 7 0. 1 0 again, which satisfies our condition. You find 1 0, you definitely cross out. So how do we do it? We said when it's column scanning, the crossing, we use a horizontal line. So look at what I would do again. I'll cross out there. Okay. Third column, nothing. It's been erased, as you can see. Fourth column has 3, 1, and nothing. Again, the other things have been cancelled out. So what next at this point? How do you know you should stop an assignment problem? Well, when your number of lines that you have crossed are equal to your rows, or maybe even the number of columns, then you should stop. What do we mean? How many rows are there? We have about 4 rows if you count this. Oh, and how many columns do we have? We have 4 columns. So I said they should be equal to either your rows or your columns, because it's a requirement for every assignment problem that they should have equal rows and equal columns. So even the lines that you'll be allocating there and cancelling out, they should equate to either the total number of rows or columns. So if you count these lines, how many are they? There are 3. Are we equal to the number of rows or columns? No, meaning our assignment problem has not ended. What do? We proceed. So what we're going to now do at this stage is that what we do is, before we proceed, the rule is that change this matrix before you repeat the same process. So what we're going to do is that to change this matrix, you identify the least number amongst the remaining and crossed out numbers in this particular matrix that I've circled. If you look at the least number among those that have not been cancelled, you will notice that it's a 1. So that 1, the rule is that you distribute it throughout the uncancelled numbers by subtracting it with every individual digit that it finds. So we're going to do this. We'll say 1, wherever it is, of course, 1 there, 1 minus 3, 2, 2 minus 1 minus 3, 2, 5 minus 1, 4, 7 minus 1 will be 6, 3 minus 1, 2, and where of course it has found 1, it will just be 0, because that least number will be subtracting every other uncancelled number and also itself. So you find that wherever there was a 1, it will now become 0. Then the rule is that where lines are meeting, the number that is on where the lines are meeting is we add 1. Yeah, the number where the two crossed lines are meeting, we usually add a 1, or should I just say it's the number that we are distributing throughout the uncancelled numbers in short. So like in this case, the number that we are distributing was a 1. So what do we mean by where the two lines are meeting? If you've noticed, these lines that we have been crossing, the vertical lines and the horizontal lines, at some point they are coming to meet, or they are intersecting each other. That just simply means what they are meeting, you have to add that number that is being distributed around, subtracting each and every individual number that was uncancelled. Yeah, in this case it was a 1. So wherever there's an intersection of those lines, you'll be adding a 1. So I've seen that with the first intersection here, where I'm just circling, there was a 1, you come and add plus 1. The next intersection I've seen is here where there's a 2, so you come and say 2 plus 1. And then you like rechange your assignment problem. Okay, so let me just quickly as well erase the screen and explain all that I've just mentioned. So if you actually just rewind the same video, you'll notice that how I came about with this new matrix that is just above there was just found by, so you'll notice that how the same new matrix came about was by the fact that after I had cancelled out those 3 lines, I had remained with some numbers that were uncancelled by the lines. So that rule is that on those uncancelled numbers, choose the least one and like subtract it amongst all those uncancelled ones, and then after that try to rewrite a new matrix after you've distributed that least number around them. And of course those numbers that were along the cancellations, this part gets it clear, those numbers that were along the cancellations, the numbers that looked like they were crossed out, the rule is that you repeat them the same way they came. So maybe just like a camera, should I say a reminder, remember there should have been a line here, I think here, and I think there was also a line here and here. So it's like you should notice these 2 rows have come back the way they were. The only difference is that here you notice the number here has changed. If you rewind the video, why has it changed? We said where the 2 lines meet, usually that number, that least number that was distributing itself around, is added on the intersection of those numbers. But that whatever number it finds in that intersection, you add with that number that least number that was subtracting around those uncancelled numbers. So there and here, those are the only changes. We added like a 1 to them, those numbers that appeared on the intersection. So now we are like at this stage now, a new matrix, and now we want to proceed. What happens after this? You repeat the same process to start scanning, row scanning, column scanning. So let's begin with row scanning first of all. Our rows are 2002. Let's start with that row first. How many zeros are there? There are 2. We said if you find 2 zeros, skip. Why we're skipping, as we said earlier on, is that you can either allocate to the first 0 or the other 0. As we said, we're trying to avoid that kind of reasoning where it's not certain. So usually when you find 2 zeros, it's not certain, so you just skip. Go to the next row, 4600. How many zeros are there? There are 2. You can't do anything as well. Just skip first. The third row, there are 2 zeros. You also skip. Fourth row, 2 zeros. You skip. Row scanning has failed to identify anything. Try with column scanning. Column scanning is now those numbers which are there with 2420. How many zeros are in that first column? 1. At least we have identified something. So when you have identified something using a 0, using column scanning, we use a horizontal line to cancel out. And we even tick the possible allocation. Go to the next column, 0602. There's only, again 2 zeros, so skip. The third column, 0023, skip. Why? There are 2 zeros. fourth column, 2 zeros. There you also skip. So you find that we only cancelled one, and it seems nothing is equating to the total number of what? Rows. We said the assignment problem continues as long as the number of rows or columns are not, if they are not equal to those lines that you have drawn, you do not stop the problem. So we have to continue this problem. So what's going to happen now is that we are going to find again a new changed matrix. It will keep changing. How do we change? We distribute the least number around what? The whole, should I say, assignment problem. The least number around the whole assignment problem, which is 0. So you find that, instead of distributing 0, everything remains the same. Huh? Like 0 minus 2 to just be 2. 4 minus 0, 4. So basically, even when we change and distribute that 0 amongst the uncancelled numbers, everything will still look the same. So what's going to just happen is that we'll maintain this very 1, because we know that when we do that, it won't change. So what we're going to just do now in this case is that we want to use so you will notice that quite alright, we were distributing a 0, which just left us with a matrix that just looks the same as the previous one, meaning we are still going to have only one line crossed as we start allocating new jobs again. What do you do in such a scenario? Why it seems like you will not be able to find your number of lines being equal to your number of rows, which are 4. When you have a scenario like this, take note of this. This is just a tip. We use what we call diagonal scanning. What is that? Well, what we do is that we go to a point where we find 2 zeros. It could be a row or a column where we find 2 zeros that are diagonally facing each other. What do I mean by that? Try the first 2 zeros that are on the top. What do we mean by diagonally facing each other? If you notice the first 0, we are in the first row, by the way. There are those 2 zeros which are on 2002. There are 2 zeros which have got diagonals there. Have you seen those two dotted lines I'm drawing? That's what I mean by diagonally facing each other. What we mean is that once you find those 2 zeros that are diagonally facing each other, you can choose any one of them. If you have such a scenario, meaning there are multiple solutions, just take note of that. Usually when zeros are so many, meaning you can assign to anyone or any person. So what happens is that this diagonal approach just helps you come and reduce that ambiguity of giving to anyone. So you have found 2 zeros that are diagonally opposite each other. You just select one of them. So maybe me, I'll select this one. And meaning if I've selected that one, what happens to the particular row, or should I say column? It gets eliminated. Okay. Then I take myself to the next one, this one which was diagonal, this dotted line just here. This one can also be picked. Okay, and if we pick this one, it also erases the whole row, leaving us with only 1 0. What do I mean? If you scan this assignment problem, first of all, the first line, when we first pick the first box, meaning it has gone, you can only assign once per row. Once per row, once per column. Just understand that. So it's like once I picked that first box after I used my diagonal scanning, what was just going to happen is that meaning I'm not going to come back to row 1 again. Row 2, when I went to what I did, okay, meaning row 1 has gone, which left me with row 2. Row 2 had now left with 1 0. Look what I meant. I'm going to cancel these lines first again. When I started, I used diagonal scanning like that, and then I said, okay, you first find zeros that are faced diagonally facing each other. That's the only way it can work. If you find 2 zeros that are diagonally facing each other, so you find that, you draw. Then now on those two, even if there are 2, it was just supposed to be 1, but if there are 2, you choose any one of them. So me, I chose the second 0 in the first row, I even put a box on it, meaning I can allocate a job there. So once I've selected this particular 0, I can erase the whole column that it belongs to. That's what I just did. So like I got rid of that, meaning, okay, that has been allocated, right? Meaning I'm never coming back to row 1 now. Go to maybe row 2, row 3, and whatnot to allocate other jobs. If I go to row 2, there is now 1 0 left. What was the rule we're using? If you find 1 0 in a particular row, you can do what? You can now cancel out the particular column. So I found this other one. It was now the only one in row 2, so at least I can assign a job there. So just like that, it becomes even easier, and I get rid of that row. What are we left with? Go to row 3. Row 3 has now got what? 1 0, meaning I can also allocate a job. So I'll just put my small box there and get rid of that particular row. This one here, I just did not mention it. For the third row, initially there was just 1 0 because I used column scanning for this last 0 that I've just boxed right now. Because if you look at the first column, there are 2 4 2 0, right? 1 0. That's how I boxed this allocation of that job. So if you count now the number of lines, how many are they? They are now at 4. How many rows are there? There are 4. Meaning the process of assignment can stop because you have assigned 4 rows, 4 lines to the equal number of rows or columns, and the assignment problem can stop. What happens next? What happens is that you have now allocated the jobs. You ask yourself, in the first row, what job operator was there? We said, okay, I think there was operator 1. If you go the first part of the video, there was operator 1. The second row had operator 2. The third row had operator 3. And the fourth row had operator 4. Then what you're just going to say is that for operator 1, give him that job which falls in which column? Column 3, right? In column 3, there was a stand name of an operator. Remember, there was A, B, C, and D. There was 10 jobs. A, B, C, and D. So meaning for operator 1, give him job what? Job C, because that 0 falls in the line for C. So 1 to C. 2. For operator 2, give him the job that falls in the line for D, because we're just following what we have boxed. So 2 to D. For operator 3, it's showing that the boxed 0 is in the line for B. And for job A, for operator 4, is boxed 0 is in the line for A. So 4 to A. What next? You go back to the original question, the first one we drew. Then you go and try and locate this point C that we have picked for job for operator 1. What number originally sat there, like on what we've boxed for job for operator 1? If you go back to the original question, the number that was originally sitting on what we allocated for operator 1, where we said C, the number that was there in that part was 2. If you go to the same one, the second row, the one we've just given operator 2, that the 0 is in the line for D, the number that sat there, it's like you just go back to the original matrix and say, what number was actually sitting here? That's what we're getting. In short, you find that there was a 6. Okay, the next one, the number that was there was a 4. And lastly, for operator 4, the number that was where the A is was 5. Therefore, you just sum up these numbers. 2 plus 6 plus 4 plus 5 equal to, that's 9, 15 plus 2, 17. Just write that well. So, this will give you 17 in total. Then it's just showing that, okay, once you assign the total jobs, the total time that will be taken will be 17 hours. Yeah, So the best way to grasp this concept is just try to rewatch the video as many times as possible, because there are certain rules that were highlighted in this assignment problem.